Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Semiconductor Electronics. So in the first part we had solved till question number 34. So in this second part of this chapter we shall start from question number 35 onwards. So any doubts if you have, then please write that in the comment section. And in any other chapter of physics, if you feel more difficulty, then also please mention the name of that chapter in the comment section. Then we shall give more priority on it and solve more and more questions on that chapter. And some important homework questions also will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. In question number 35, it is told the DC common emitter gain. The DC common emitter gain that is called as beta DC, that is equal to 50. The potential difference applied across the collector and emitter of a transistor used in CE configuration is VCE equal to 2 volts if the collector resistance RC is 4 kilo ohm and the base current IB and the collector current IC are how much. So we know that VCE, that is equal to IC into RC. So IC will be equal to VCE by RC. So that will be equal to 2 volt divided by 4 kilo ohm. So 4 into 10 power 3 ohm. So this will be by 2, so 0.5 milliampere. And we have to find IB also. So we know that beta DC, that is equal to IC by IB. So therefore IB, that will be equal to IC by beta DC. So that will be 0.5 milliampere divided by 50. So this will be 0.5 by 50 into 10 power minus 3. So this will be 5. So this will be 0.01 into 10 power minus 3. So this is 10 into 10 power minus 6 ampere. So this is 10 microampere. So IB is 10 microampere and IC is 0.5 milliampere. So option A is the correct answer. Question number 36, it is told the conductivity of a semiconductor increases with increase in temperature because the number density of charge carriers increases and the relaxation time decreases, but the effect of decrease in relaxation time is much less than the increase in number density. Since we know that I is equal to VD and velocity, okay. VD, that is equal to VD is inversely proportional to the relaxation time. So the relaxation time decreases. If the relaxation time decreases, then the current increases. Now the conductivity sigma, that is equal to Ne square tau by M. So it means sigma is proportional to N into tau. So now when the relaxation time decreases, then the conductivity sigma should decrease, but when the number density of charge carriers will increase, then the sigma will increase. So when the temperature increases, the relaxation time decreases and the number density increases, but the increase in the number density of charge carriers is much higher than the decrease in the relaxation time. So the net effect is that when the temperature increases, the sigma, the conductivity of the semiconductor increases. Since n increases more than and tau relaxation time tau less decreases, it decreases less. So option C is the correct answer. So in question number 37, is told that for a transistor amplifier, the voltage gain is low at high and low frequencies and constant at mid frequencies. Option A is the correct answer. Question number 38, it is told in the following circuit, what are P and Q? So here, this is one, this one is 0. This is Q. This input is P. So 1 or P. So this P. It means P is 1 or Q, but not of that, since it is NOR gate, and Q is equal to 0 or P, but not of that. So therefore, P will be equal to 1 or this is 0 or P, no, it's whole not. So therefore, P will be equal to 1 not and 0 or P double not. So this is equal to 1 not, that is 0, and 0 or P, that is P. So 0 or P, that will be P only. Since if P is 0, then it is 0, if P is 1, that is 1. So this is 0 and P. Zero and with something, that is 0. So P is equal to 0. P is equal to 0. So Q is equal to 0 or 0 and it's not. So 0 or 0 is 0 and it's not is 1. So Q is 1 and P is 0 and P is 1. So option A is the correct answer. Then it is told a positive hole in a semiconductor is the a vacancy created when an electron leaves a covalent bond. So option D is the correct answer. In question number 40, it is told 220 volt AC supply is connected in between points A and B as shown in figure. What will be the potential difference V across the capacitor? So here the voltage applied across A and B is 220 volts. So the potential difference also will be, so this is forward, this PN junction diode is forward biased here. So across the PN junction diode here, there is so it will conduct, so it will become fully charged after some time, and it will instantaneously get charged. So the maximum voltage of the AC source, so this 220 volts, this is the root mean square or the RMS voltage of the source, RMS voltage of the AC source. So therefore the peak voltage is V naught, that will be equal to 220 into root 2 volts. So the capacitor will get charged by this peak voltage, 220 root 2 volts. So option B is the correct answer. Then in question number 41, it is told the following circuit, what are P and Q? So here, let's suppose I take, so this is 1, so this is Q, so this input is Q, here this input is P. So therefore from here we can see that P is equal to 1 and Q, and since it is a NAND gate, it is a NAND gate, this is, so this is 1 and Q whole naught. Q is also equal to 1 and P whole naught. Okay, sorry, it is 0 and P whole naught. This is, sorry, this is 0 and P whole naught. So therefore I can say that P is equal to 1 and 0 and P whole naught, and then it's again whole naught. So if we apply the De Morgan's law, then this will be 1 naught or O and P double naught. This will be 1 naught is 0, or it is 0 and P, that is 0 only, since 0 and 1 is 0 also, and 0 and 0 is 0 also. So 0 double naught, so this is 0, so 0 or 0, so this will be 0. So P is equal to 0. So therefore Q will be equal to 0 and 0 whole naught. So 0 and 0 is 0, 0 and 0 is 0, it's not, that is 1. So P is 0 and Q is 1. So option D is the correct answer. In question number 42, it is told that the circuit given represents which of the logic operations. So here the input, let's suppose here the input is A, this is B, so it is A, so it is a NAND gate, here also it is a NAND gate, so this is A and B whole naught. So here we have A and B whole naught. So let's suppose this is equal to C. So here also the input is C, here also, here both the inputs is C. So this output will be C and C whole naught. So C and C whole naught. So C and C, that will be C naught. Therefore the output that will be C is A and B whole naught. So that will be A and B whole naught, it's not. So A and B double naught. So that is A and B. So this entire logic operation is the AND operation. So option B is the correct one. In question number 43, it is told identify the incorrect statement. When a PN junction diode is forward biased, the width of the depletion decreases. When a PN junction diode is reverse biased, the barrier potential increases. A photon diode is operated in the reverse bias. LED is a lightly doped PN junction diode which emits spontaneous radiation of forward biasing. Yeah, so it is not a spontaneous radiation. So option D is the incorrect statement. So it is the correct answer. In question number 44, it is told 3 photodiodes D1, D2 and D3 are made of semiconductors having band gaps 2.0 So the photodiode D1 is having band gap 2.5 electron volt. The photodiode D2 is having band gap 2 electron volt. The photodiode D3 is having 3 electron volt as the band gap. Which one will be able to detect light of wavelength 600 nanometer? So first we have to find what is the energy of a photon having wavelength 600 nanometer. So E, that will be equal to hc by lambda. But hc is 1242 nanometer electron volt, that divided by lambda, that is 600 nanometer. So nanometer will cancel, so this will be 600 and this is 6 2 are 12, 6 7 are 42, so it is 2.07 electron volt. So this energy is more than the energy band gap of the photodiode D2, and this energy is less than the band gap for D1 and less than the band gap for D3. So D1 and D3 will not be able to detect this light of wavelength 600 nanometer. So only D2 will be able to detect this light of wavelength 600 nanometer. So only the photodiode D2 will be able to detect this light. So option C is the correct answer. Then in question number 45 is the last question of this chapter. So which logic gate is represented by the following combination of logic gates? So here, which logic gate is represented by the following combination of logic gates? So here the output will be A naught, here the output will be B naught, and Y will be equal to A naught or B naught and its whole naught. So that will be equal to A double naught and B double naught. So this will be equal to A and B. So it means that this combination of logic gates is similar to the AND gate. So option A is the correct answer. So hope, okay, so here, sorry, one more last question is there. This question number 46. So here it is told the forbidden energy gap for germanium crystal at 0 Kelvin is. The forbidden energy gap for germanium crystal is 0.71 electron volt. So option D is the correct answer. So hope all of you have understood the solutions of these 46 questions on the chapter Semiconductor Electronics. So still any doubts if you have, then write that in the comments section. We shall obviously clarify them. Please install our Sapience education application, where we shall upload some important homework questions based on the previous year KCET exam, which shall be helpful for your exam. So thank you everyone. Bye.